Okay, so here is the notes on what was my honors class 2.7 piecewise functions. We're going to be we're going to be able to evaluate a piecewise function, and we'll be going over how to graph a piecewise function also. Since we're going over both of these the same day, then I'll go kind of faster since we've taken notes on it already. Um, all right, so function notation, went over this in class. So basically, well, this should be a required one or a required previous skill that you should already know. So function notation, we went over why that was a more convenient for sciences and things like that. Basically, the y turned into an f of x, and you know it's a function. So piecewise function, here's a definition. It will look like this. So basically what happens is it's called a piecewise function because you have actually two pieces to this function, the top part and the bottom part. So the parts I just circled in red, those are basically, you can consider this as saying f of x equals the top part, and f of x also equals the bottom part. So it equals both of those. Um, Now, the way you figure out where to plug in your value, because normally when you have a function, you have an x value or a domain that you plug in. So let's say we had x equals 4. Now the problem is, right now, if you've never seen this before, you're not sure if you're supposed to plug the x into the bottom part or if you're supposed to plug the x into the top part. Okay, and you're not supposed to plug it into both if you have a function, because a function should only have one output. If you plug a 4 into both of those, you'll get two values coming out, which you're only supposed to have one. Now, the way that we remedy this is over here. We have what's called a domain restriction. So the domain restriction on the top says that, hey, use the top part for x values that are smaller than or equal to 1. The bottom part says use the bottom part for the x values that are bigger than 1. So looking at x equals 4, x equals 4 is bigger than 1, which matches this requirement. X has to be bigger than 1 to use the bottom, so you would plug this into the bottom part. So if you plug the 4 in, you get 3 times 4 is 12, plus 1 is a 13. Okay, that's basically how that works. So let's do an example of this. Actually, let's move to a kind of more difficult one. So with this one, we have two piecewise functions. One says f of x, the other one says h of x. So looking at this first one, this is f of 7. So since it's f, I'm going to go ahead and look at the f function. Looking at the 7 part, so looking at your domain restrictions right here, 7 is bigger than a 1. So we're going to use the top because it says f of 7, 7 is bigger than a 1. I would use the bottom part of this one if x was smaller than a 1. So the way I would do this, I would say, okay, f of 7 equals 3 times 7 plus 1. That's basically just substituting it into the top part. So f of 7 is equal to 21 plus a 1, which is 22. So f of 7 is 22. When you plug in a 7 into our function, you get a 22. Now, if looking at the second one, let me erase some of this stuff here. Okay. Looking at the second one, h of negative 2, since it has h as your function, you should be looking at the h of x function. Negative 2. So look at your domain restrictions. It's based off of a 3. So you're going to use the top when your x's are smaller than 3. You're going to use the bottom when your x's are bigger than 3. So negative 2 is smaller than 3. So the smaller than 3 function is the top function right there, since negative 2 is smaller than 3. So you would use that one. So h of negative 2 equals negative 2 squared minus 10. So that's going to be a 4 minus a 10. Whoops, that's 16. Which equals a negative 6. So h of negative 2 equals negative 6. Okay, next one. Okay, I'll do in green. This is another h of 3. So I look at the h, so I know I'm using that one. 3 is equal to 3. So there's your 3's. 3 is equal to 3. This inequality says less than or equal to, so we should be using the bottom. Can't use the top because the top is reserved specifically for x values that are smaller than 3. not equal to 3. That's for the bottom part. So it's going to say h of 3 equals 2 times 3 plus a 5, which is 6 plus 5, which is an 11. So h of 3 equals 11. All right, and last one, and then we'll get into some graphing. So the last one says f of 0. So looking at the f, this is f function, which means you're going to go back to the f function. Look at the x value, because this used to say f of x. X is now a 0, so that's your x value is a 0. So looking at the domain restrictions, 0 is smaller than 1. So that means we're going to be choosing the bottom, because the bottom says it's reserved for x, or the domains are reserved for x or smaller than or equal to 1. So f of 0 equals negative 5 times 0 plus a 2. Anything times 0 is 0, plus 2 is 2, so FO equals 2. Box, box, box. And that's how you would evaluate a piecewise function. Now we're going to get into graphing this, because not only do we want to know how to use this stuff with evaluating, but you should know how to graph it, because graphing is basically the visual representation of any equation. So there's two parts here. Basically, hold on. So let me do this real quick. Cut. Wait. Whoops. Nope. Yeah. And I'll put this here and shrink it down. Okay. Here's what's going to happen. Now, if I look at the domain restriction part, that's this. So what's going to happen is I'm only going to want to graph pieces of this line. You know what? Let's make this a little more here. Or actually, never mind. So your break line, you know what? I'm getting ahead of myself. Let me erase this one though. Sorry. Okay, here's what's going to happen. Your domain restrictions that were on the side, what's that going to do? That's going to give you what's called a break line, because you're going to be breaking the lines that you're about to draw into two pieces. So if you remember before, I said that piecewise function is made up of two other equations are put together to make basically a piecewise function. So the way ours are going to look are like this. You're going to have two equations that you can turn your piecewise function into. So you're going to graph both of those. So let's say that one of the graphs look like this. So you draw a line, make the graph. Now, what happens here is you have a point of intersection between that line and what I'm calling the break line. I don't think that's a mathematical term, but let's say that you had that. Okay. Now you're going to have a second line that you're going to draw. So let's say this line look like this. Okay, so I'm just going over the steps that we're eventually going to do. There's not even a function that's up here right now. And then this line is going to break also. Now notice I have an open and a closed circle. Each of these two functions, each of these two lines, you're only going to keep pieces of the line. So what's going to happen here is I'm going to look at the point where, so I'm looking at the black line. The black line crossed that green dashed line at that point I just put on there. So I'm going to want to keep a part of that line. And then I'll show you guys how to know what part. But basically the part that I don't want, I'm going to erase all the way up to the break line. So the break line, quote unquote break line, is going to break it into two pieces. You're going to throw, for all intents and purposes, you're going to throw one piece of the line away. Same thing with the blue line. The blue line broke with an open circle. So what's going to happen is I'm going to pick one side to erase because I don't need that side. And this is basically what our piecewise functions will look like with linear equations. Okay, you can do piecewise functions with other types of things, but we're sticking with linear equations right now. I know that's kind of a lot if you've never seen this before, so let's go ahead and go through the steps and actually do an example. Couple steps here. First, when graphing a piecewise function, identify what I call the break line. This will be associated with the domain restrictions. Next, this is optional, you don't have to do this, but you can rewrite the piecewise function as two separate equations. Third part, graph the first equation like any other line, because we're in linear piecewise functions here. Determine how it breaks with an open or closed circle. Determine which part to keep, and then do the same for the second equation, and then that's it. So looking at this concrete example. First off, like we said, or like I said over here, identify the break line. The way you're going to do that is by looking at this piece right here. That piece will tell you where to put your break line. So if you notice, I want my x values to be either smaller than 1 or greater than or equal to 1. So what I'm going to do is I'm going to go over on my graph over to 1 on my x-axis, which is right here. Okay, that's at 1. Now I'm going to either want stuff on the left side of 1 or on the right side of 1. So what I'm going to do is I'm going to split my graph at 1. So right now, I'm looking at this. I'm either going to be looking at the left side of that blue line or the right side of that blue line, depending on what my domain restrictions say right here. Okay, so now at this point, I'm going to split this into two separate equations. I'm going to have a top equation and I'm going to have a bottom equation. Now I'm actually going to write it as y equals 2x minus 3. That's the top equation. Now I only want that top equation if my x values are less than 1. Okay, so let's focus just on the top part for right now. So everyone should know how to graph this part. This is a previous requirement. So your slope here is 2. To graph it, you need it 2 over 1. Y-intercept is a negative 3. Okay, so let's graph that. So we start at negative 3. So you go down 3, put a point. Then we're going to go up 2 and right 1. And now draw your line. Okay, so all we did there was we drew the line. Now, if you see where this line gets broken, that's why we call it a break line, right where it touches that blue line. So now we have a right side of this line, and we have a left side of this line. So we're going to look at our domain restriction, which says x is less than 1. If you think about a number line, less than symbol means you're looking for values on the left. So since I want values on the left, I'm going to keep this left side of the line, and I'm going to discard the right side of it because it doesn't say it wants greater than 1, it wants less than 1. So that's the left side. Okay, looking at it with this, like if I see the entire graph, I'll line this up right here. I only want that piece because over there, this entire side right here is basically the left side because that's less than 1. Okay, I don't know if that was helpful or just confusing. Hopefully it wasn't confusing. Let's do the bottom part now. Let me erase some of this stuff so there's too much stuff around here. So on the bottom, I'm going to rewrite this as y equals negative 5x plus a 6. Now, I only want that if my x's are greater than or equal to 1. So basically all I did is I just rewrote this just by itself so there's not so much stuff around it. I'm going to graph it. So m equals negative 5 over 1. My y-intercept is a 6. So I'm going to start at 6. So 1, 2, 3, 4, 5, 6. It's up here. Then I'm going to go down 5. 1, 2, 3, 4, 5, and over 1. Okay. And I'm going to draw this line. Okay. Keep in mind, I don't even care about the black line anymore. I'm just focusing on the green one. Now, I want my x values to be bigger than 1. So I have a left side of the green line and I have a right side of the green line. I don't care that they're pointing up and they're pointing down. What I care about is there a left side and a right side. When I have x values that are bigger than 1, think about a number line because the x-axis is like a number line. Bigger than 1 on the x-axis means to the right. So I want to keep the right side of this green line. That means I do not want the left side of the green line. Okay. Now, one thing is here, if you noticed, hopefully, I skipped one of my steps. One of the steps said determine how it breaks, open or closed. So just like when we used to graph on the number line, if there's a line underneath and it's equal to 1, it's a closed circle. If there's no line underneath, like this one right here, it's an open circle. Okay. What I mean by that is the top one, which was the first line we drew, it's going to break with an open circle right here, not a closed circle. And then the second line that we drew, since it's less than or equal to, the breaking point is going to be a closed point. And then there's your graph. Let me make the open circle a little more open there. And there you go. Um, so I'll do one more here. Another one. That's a step function. So let's do this one. Forgot a little equal sign here. So like I said before, focus on the break line. It's always going to line up in this class, so it's going to be at -2. So I will make the break line at -2. Make it dashed because it's not actually there. Um, so x is -2 is right here. Okay. There's your break line. X equals -2, so I went left 2. It's always going to be vertical. So that's taken care of. Now remember, that's making me focus on either the left side or the right side of the green line. So I'm going to write my first equation as y equals 1/2 x minus a 3. And then I'm going to do that for x's that are less than -2. Maybe a good idea to do is look at this right now. X is less than -2. That is left on a number line. So after we draw this, we're going to focus on the left side of whatever we drew. So we're going to start at -3 on the y-axis. This is still just graphing like a normal graph. Here's that. Then you're going to go up 1 and right 2. Now notice I didn't put a point on the green line, but I don't care. I don't need to put a point on the green line. All I need is my lines to intersect. And there you go. They intersected. Okay. So looking at where my the line I just drew crosses the green line, it should be an open circle because this is not equal to -2. It is strictly less than -2. So I'm going to break this with an open circle right there. Now the next thing I want to look at is what I just said right here. I said that I want it to the left. So the left side of this line that I just drew is this side because that's going to the left. So I erase all these pieces. There you go. That's half. Now for the other half, do the exact same thing for the bottom. So y equals -3x plus a 5, but I want this for x's that are greater than or equal to -2. Greater than on a number line means to the right, so maybe writing these words down right below it will let you know which side to keep. So starting at +5, 1, 2, 3, 4, 5, I'm going to go down 3 and write 1. And this is going to cross way up here. Now, if I extend this green line, okay, the nice thing about this, so it's gonna break with a closed circle because of the equal to sign. So the break is right here. Now, keep in mind, it keeps going to the left also, but we want to keep the right-hand side anyways. So I can't really erase. So there was stuff up here, but we don't need that anyways. So we're just keeping that side. All right. And that's the graph of that piecewise function. If you look at it, it's actually pieces of 2 lines. So that's why it's a piecewise. All right, so that's it for the piecewise functions. You do have a test tomorrow, so be ready for it.